Okay, so today we're gonna find excluded values for rational expressions, and these are called rational expressions because the word ratio means to compare two numbers, using division, sometimes they say, or see how many times you can divide one number by another. Those are ratios, in other words, fractions. So when you hear the word ratio or rational, you should be thinking fraction. So we're going to state the excluded values of these rational expressions, and we're also going to simplify them today. So that's what we're going to be doing in this video. So first, let's think about simplifying them. Now, you've seen something like this before where when you worked with your properties of exponents, you were just going to go ahead and simplify these exponential expressions here, just like you would using your exponent rule. So if you remember, the way that I like to think about it is I like to think about where are there more x's? Are they at the top or at the bottom? And in this case, there's more at the top. So when I cancel them out, or I think about this one as this would be what, 7 x's up here and 4 down here. What's going to happen is when you start to divide them, so x divided by x is 1, x divided by x is 1, x divided by x. So what's going to happen is the leftover ones are going to be at the top. Now, if you remember, the rule is, that you learn is when you're dividing, you subtract the exponents. So I always just, but sometimes you end up with a negative, and then you got to deal with the negative. So I always just say subtract the little one from the big one and put it either in the top or the bottom, depending on where the bigger one was first, right? So in this case, we're going to have 3x over 2. 3x to the third over 2, because there's 3 x's left. Okay, 3x to the third over 2. Now let's talk about our excluded values. What's going to cause an excluded value here is, well, basically anything that's going to cause this denominator to come out to be a 0. And why is that? Well, you can't divide by 0. By definition, 0 can't be a divisor. And why? Because division is multiplying by the reciprocal. And if you remember, reciprocals are two numbers that multiply to 1. So there's lots of numbers that multiply to 1. Immediately, we always think 1, but there's actually tons of numbers that multiply to 1. 1, you could do 1 times 1. They would be reciprocals. But you could have 1/3 and 3. That would also equal 1. Or 2/3 and 3/2. That would also equal 1. So all reciprocals. Or -3/2 times -2/3, right? Those would also be reciprocals. So there's lots of numbers that multiply to 1. But we already know, using the zero product property idea that we've learned in the past, that the only number that multiplies, if you multiply by a 0, you multiply any number, you're never going to get a 1. That's never going to happen. So the only result I can get here is a 0. So 0 does not have a reciprocal, which means he can't actually divide anything. And just think about it as your second grade idea, right? Usually we say, if we say 1/2, we're saying we're dividing something into 2 parts. So if I take this paper, I can divide it into 2 pieces. So now I have 2 pieces instead of 1. Or if I change it to a 4, I can cut this into 4 pieces, right? But is it ever possible to cut it into 0 pieces? So even if you think about it with like your second grade kind of understanding of division, dividing by 0 doesn't make any sense. So excluded values are basically, for these ones, for rational expressions. Think denominator can't be 0. Okay, so the denominator can't be 0. Sometimes there's a couple more rules that we have to look at, because there might be some rational expression that has other things that have restrictions. But generally, that's the first thing I should be thinking. What's going to make the denominator equal 0? So how do I figure that out? Well, I set it equal to 0. And we get x to the fourth is equal to 0. So x to the fourth is equal to 0. Well, we just said how do you get something to be 0? So x is equal to 0 here. So in this case, we say x cannot equal 0. That's my excluded value. Okay, so that would be how we describe the domain, maybe they would ask you. Sometimes they use the word domain. Excluded values. You can say x cannot equal 0, or you can say your excluded value is x is equal to 0. You can say it these two ways. Okay, so your excluded value is x is equal to 0, or you can say x cannot equal 0. I think either of those anybody would accept as a good answer. Okay? All right, let's take a look at this one. Now, this one's a little more complicated because it's harder to see what's going to make the denominator 0. And it's harder to figure out what I'm going to divide out or cancel out, sometimes people say. So what we're going to have to do is we're actually going to have to factor this one. We're going to have to factor the top, and we're going to have to factor the bottom. So let's take a look about factoring our trinomial, right? So let's factor the top first. Now, I know that I'm going to need, so I'm doing this guy here. I know that I'm going to need factors that multiply to 3, so that's easy. It's got to be a 3 and a 1 if it's factorable. And again, let's face it, a lot of the time they're going to give you ones that are factorable because otherwise it'll be hard to do the question. So a lot of times they're going to give you these ones that are factorable when they say to simplify. So at least go into it assuming that there's a chance it's factorable. Okay. Now, what do we need to get to multiply to x's? Of course, x squared, we need x times x. And now I'm going to check my little smiles here, right? So I have 3x and x. And I need them to come out to be a -2, which means I need this one negative and this one positive to give me my -2, which means I need this smile to come out negative and this smile to come out positive. So I factored the top, okay? Now, underneath that, what are we going to have? So now I'm going to do the one underneath. So the denominator. So now I'm going to do this guy. You ready? All right, now I need things that multiply to 4, but add to 5, right? So when I make my smiles, we need to have a 5. So let's face it, 2 and 2 is not a good choice. It's got to be the 4 and the 1, right? And I know that my x squares come from an x and an x. So I need a positive 5. And so I want these both to be positive, all right? So I'm looking at something that looks like this. I'll write it over here. X minus 3, x plus 1. And on the bottom we had x plus 1, x plus 4. And obviously, you know, I could have written them either way. Multiplication is commutative. It doesn't matter which one was in front. Okay? Now, in order to simplify this, so we'll simplify it first and then we'll worry about our excluded values. To simplify this, what I'm going to do is basically the same thing I did up here. I'm going to cross out the things that are the same, right? So what things are the same here? It's this guy and this guy, right? There's those factors are both on the top and the bottom, or that factor both on the top and the bottom. And what are we left with? We're left with this, x plus 4. So this is my simplified, right? So that's the simplified part of my directions. Now, if we want to write our excluded values, you may think, well, I only have to worry about this denominator. But for a question like this, we actually have to go back to the original one. So whenever we're finding excluded values, always look in the original, right? So I'm going to make sure that you hear that more than once while we're talking. So always think about the original one when we're using it, when we're looking for excluded values. So if I'm looking for excluded values here, I am actually going to do the same thing I did before. I'm going to set this denominator equal to 0. Now the good news is, so I want to know what will make this denominator 0 and basically throw those numbers away, right? Because we don't want the denominator to be 0. The good news is I already factored this denominator, didn't I? I did all the hard work already. And how would you solve this? Of course, it's a quadratic. You'd solve it by factoring. So what will we do from here? We'd use our zero product property to say that one of these factors has to be a 0. So I get x is equal to -1 and x is equal to -4. And so these are my two values these are my excluded values, so I could name them excluded values. Or if it came up and they said, what's the domain? Sometimes I just say x cannot equal -1, x cannot equal -4. You could also write it, sometimes they write it as, like a set number. You could use a set, x cannot equal this set of numbers. Any of those kinds of ways that you want to say it. So these are the values that will make this thing undefined, basically. You can't use a -4, and I can't use a -1 in here because we'll be dividing by a 0. And this is my simplified one. All right, you ready? We'll do a couple more. Here, why don't we skip ahead to this one? All right, so this one's, what we're going to do is we're going to simplify, and we are going to find our excluded values again. So again, the first thing I'm going to do, I'm going to work across this time. I don't usually like working across, but I'm kind of going to make a mess, so I'm going to try to factor here. All right, so let's see. I need factors of 2 and factors of 6. They're going to need to add up to a 7. So this one is the one I know if it's factorable that it has to be a 2 and a 1, so I'll put those ones in first. Okay, now I'm going to try to get to a 7. So let's just think about this for a second, right? I'm going to use a light color one. If I put a 6 here, that means that I'm going to be multiplying these two together and these two together. And that will give me a 12 and a 1, right? Obviously, that's too big. So, and if I put the 6 here and the 1 here, this is going to give me, now it's going to give me a 6 and a 2, which is never going to work out. It's not going to give me the 7 that I want, right? So I immediately know the 6 is no good. And I probably could have figured that out without writing anything down. Like, I feel confident that I knew enough that it wasn't the 6, okay? Just because I knew that to get to the 7, that didn't seem like a likely choice, okay? So the ones I'm going to be looking at are 3 and 2, okay? So I just have to decide how to put them so that I get a 7. And again, most of us think of 7, maybe you're going to think about it this way. So this one is going to give me a 4, and this one's going to give me a 3, right? Which will give me the 7 that I want. So when I'm doing these ones, I'm just I'm guessing and checking, but I'm eliminating all the bad guesses, right, first. And of course, we need it to be positive, and this is positive, so these must be positive. Okay? Now, underneath here, we're going to have this one. Now, this one's a little bit trickier. But again, I feel like the 6s are not going to be the option here because we have a 5 in the middle. So I think I'm going to have to deal with 3s and 2s again. So I'm going to try a 2 and a 3 again, and a 2 and a 3 for the first one also. I need a 5, so I guess I want the 9 and the 4 would be good. So this would give me a 4, and this would give me a 9. I need a -5, so I want this one negative, positive, and now I'm just going to put in my x's. Okay, so now the fraction that I'm working with is 2x plus 1, 3x plus 2, and 2x minus 3. Okay, so this is what I rewrote these two things. This one and this one say the exact same thing. All right, again, if we simplify it, then we know that we're just going to divide out the ones that are the same, because, of course, 3x plus 2 over 3x plus 2 gives you a 1. So these two things actually reduce to a 1. So like we think about as crossing them out, but really what we're doing is we're dividing them and making them a 1. And so now I have 2x plus 1 over 2x minus 3. All right, so now it is simplified. There's no more factors for me to, divide out. So I guess I should say simplified, right? It's already simplified. All right. So there he is. Now let's talk about our excluded values. So when we have our excluded values, since this denominator and this denominator are the same, I'm going to use this denominator to figure out my excluded values because it's already factored, so why go back to that other one? So what I'm going to do is I'm going to see what makes this denominator, and for some reason I wrote them the opposite way, but that's just because my hand went crazy and wrote a 2 first, but obviously it doesn't matter which way I write them, right? Okay. Now, a zero product property says that one of these has to be 0 to make that true, so I'm going to figure out what makes that 0, and I'm going to figure out what makes that 0. And so this one comes out x is equal to 3 over 2. And this one is x is equal to negative 2 over 3. And these are my excluded values. And again, how you choose to write them, there's different ways you can write them. You could just do it this way and just literally say excluded values if you want. Okay? So basically, to sum up, what are we doing when we're simplifying and finding our excluded values? You're finding the factors that are common on the top and the bottom and canceling them out or dividing them and making ones out of them. Then you're setting the original denominators equal to 0 and figuring out what values make those denominators come out to be 0. And you're calling them excluded values because they're ones that we can't use. We're excluding them from our choice of numbers for x or our domain. Okay? And it doesn't matter how complicated the factoring is. The first thing you do is just try to factor them as best you can. And then as soon as you have nothing else that's the same on the top and the bottom, you're done with your dividing, your canceling, then you know that you're done simplifying.